All right, welcome to the review for the mini test on evaluating scatter plots and special functions in regression. So, we're going to go through the problems that are on the review. The first problem is the concentration of a medication in a patient's blood as time passes is given by the data in the following table. So the first thing we're going to need to do with this table is to put the data into the calculator. So we'll bring up our calculator. You would take out your calculator and bring up the calculator, and we're going to put the data in. So in order to put the data in, we're going to click Stat, Edit, and we will put the time in L1. Very important that we put the correct concentration values with the correct time values. So, once we have the data in, we're ready to go. And the first question is, does the data appear to be linear, quadratic, or exponential? So in order to do that, we're going to have to look at the scatter plot of the data. So in order to do that, we will go ahead and turn the stat plot on. We want to make sure we have a scatter plot selected, so we do. So we'll quit out, and then we're going to want to zoom. And the number is 9, but I just want you to see that it is zoom stat. And there we see our scatter plot. Now, our choices are linear, quadratic, or exponential, so clearly this is quadratic. So it says, what is the line or curve of best fit? Be sure to define your variables. Well, we already defined our variables. We said x is time and y is concentration. So x is time in hours and y is concentration. And the units on that are milligrams per liter. But we need to find an equation to relate those two variables. So we will go back to our calculator and we will go to Stat, Calc, and we will find the regression equation. Now, once again, we can see that our graph is quadratic, so we're going to use the quadratic regression. And I have the option of storing the regression equation in y1. I'll go ahead and take that, and I will calculate this. And what I will get is this. Now, remember, we're using this to estimate data. And as we can see from our graph, it is not a perfect fit. And so what we want to do is we just want to be reasonably close. And so we're going to go to like 2 decimal places here. So our equation would be, if we're seeing this, is going to be, it's going to disappear, y equals negative 56.21 x squared plus 139.31 x plus 9.35. And so there is our equation. We've defined our variables, so we're okay. So it says, based on your model, how much would medication in the patient's blood would you have after 3.5 hours? So we're going to go ahead and plug 3.5 in for x, because x, as we said, represents the amount of time in hours. So as we write in our thing here, and when we evaluate this, what we will find is we get a negative value. And you're going to have to give me a second to put it in the calculator. I get y equals negative 191.63 approximately milligrams per liter. But let's go back and talk about our model. The model is modeling how much medicine is in the patient's blood. And when we look at the graph here, I'm going to put my pen down. As we look at the graph here, what we notice is that right here, the concentration of medicine is 0. And it can't go negative. It's just going to stay 0 from then on. Our model breaks down at points past that. So our correct answer here is actually 0 milligrams per liter is what we'd expect to be in the patient's blood after 3.5 hours. And this confuses a lot of people. It's like, so when it's negative, that means it's 0? No. We have to look at the model. We have to look at the context of the problem and say, do negative values, make sense? And if negative values don't make sense, then let's look at the model and see what value does in fact make sense. All right, so for this one it says define your variables. Well, variables are already defined as x and y. It's not a real world situation. We're just making sure that we know how to model things on the calculator. So we'll go ahead and put our data in. So we'll go to Stat, Edit, and remember the tip is you do not want to delete data. Instead what you want to do is clear your data. You don't want to delete the list. 0, 1. And we'll go ahead and enter the data into L1 and L2. There we go. And then we're going to want to look at our data. One of the tips is you want to make sure you clear out anything you were doing before. So we don't want to graph our equation from the last problem. So we clear that out. And then we're going to zoom 9 to zoom in on the new data set. And what we see is a shape. And the question we got to ask ourselves is, this curvature here, does that look quadratic to us or exponential? And at least to me, that looks like an exponential. So let's go ahead and use an exponential model and see how well that would fit. So we're going to go to Stat, Calc, and we'll go ahead and choose the exponential regression model. X's are in L1, perfect. Y's are in L2. I'll go ahead and store the regression equation again. Remember, you can use F4 to get that out. And then we just go calculate. And we should get our regression equation. Now, some things that confuse people is that what does that little caret there mean? Well, what the caret means is to the power. So what this is really saying is y to the a times b to the x. And so that's the form we're going to want to write it in over here. So we'll say y equals 5.03 times 1.49. Oh, I can't remember. Let's see here. 1.0496 to the x power. And there is our curve of best fit for the data. Give the equation of a line that passes through 4, 7, and 7, -2 in point slope form. So remember that slope equals y2 minus y1 over x2 minus x1. And so what we're going to want to say is we want to label our points x1, y1, x2, y2. So slope is going to be someone's yelling next door. Slope is going to be -2 minus 7 over 7 minus 4. And we'll get -9 over 3, or -3 is our slope. So, but that's not in point slope form. That is just the value of the slope. Point slope form of a line is y minus y1 equals m times x minus x1. So we now know that m is -3. And as we saw up here, we already have x and y1, so this is y minus 7 equals -3 x minus 4. And there is our equation in point slope form. Now it asks us to find the slope in the second one in slope-intercept form. So we get y equal, which is this form here. And this is easy enough. If we already have an equation of the line, all we need to do is to solve it and get y by itself on one side of the equation. So we'll distribute the 3. We'll get -3x plus 12. Add 7 to both sides, and we'll end up with y equals, and now it's in slope-intercept form. And the other side is y equals -3x plus 19. Notice the slope hasn't changed. It's still -3, but the y-intercept we now know is 19. All right. For this one, draw and give an estimate of the line of best fit. So I'm going to cheat a little bit here and get the calculator to get the smartboard to draw the line for me. Now there's a couple different ways to attack this problem once I get it like this. No, that's not quite right. Let's see here. That looks good there. That looks good there. All right, I'm okay with what I got. So there's a couple different ways. One is I could find 2 points on the line and find the slope-intercept, point slope. Or I can just look at the line and say, hey, what is the slope? So let's pick a point. This point here on my line is 0, 1. And that's a very useful point to have because that's the y-intercept. I need another point, and I have this point here, which is 2, 2. So between these 2 points, I rise 1, and I run from 0 to 2. So this is 1, 2. So my slope is 1/2. And so the equation of my line is y equals 1/2 x plus 1. With 1/2 being my slope and 1 being my y-intercept. Now I could have picked another point on the line and done it another way. I could pick 2 points on the line, find the find the location of those points, and then do it exactly the same as doing this problem right here. So those were the problems on the test review. If you have any questions on anything I didn't explain, please bring them to class and be prepared to ask them before we start taking the test.